Here we'll use substitution instances to check our rule usages. Using substitution instances is a great way to develop rule pattern recognition skills, to understand why and when a rule usage is legal or illegal, and also to guard against rule accidents. It's really important to get in the habit of self-checking your proofs, and substitution instances are a surefire way of making sure that you've used your rules correctly. To get started, we need to know what a substitution instance is. This is a concept that we first got in Chapter 11, and a substitution instance really is kind of what it sounds like. It's a specific instance of a general or abstract pattern. In Chapter 11, these are what our substitution instances look like. The top one is a specific instance of this general or abstract reasoning pattern. And we know that because the logical operators are the same, and the components are uniform replacements or substitutions as well. Wherever the first is, Aristo is teaching replaces the first, and wherever the second is, Bloppo is listening replaces or substitutes for the second. Now, importantly, our inference rules are stated as forms. If you notice in the book, these were bolded, capitalized letters. In other words, these stand for any sentence of TL. They don't stand for specific sentences of TL. And just as importantly, any particular use of a rule is correct if and only if the particular use is a substitution instance of the rule. So for example, taking MT, this is our basic rule pattern. If you tend to be a little bit more visual, I encourage you to use colors or even shapes to draw your attention to the rule patterns. Whenever you do this, make sure that all the logical operators stay intact, that those are exactly parallel. But the bottom line here with rule MT is given a conditional and the negation of its consequent, you're then authorized to derive the negation of the corresponding antecedent. So for instance, this is a substitution instance of rule MT. You have a conditional, the negation of its consequent, and the derivation of the negation of its antecedent. Here's another substitution instance that might be a little more difficult to see, but we do have the same pattern. We're given a conditional. We also have the negation of the consequent, and that allows us to derive the negation of the antecedent. And as a final example, we have the negation of the consequent, and we are deriving the negation of the antecedent. So that's the general idea of using a substitution instance to check your inference rules. So the thing to remember here is that a particular use of a rule is correct if and only if the particular use is a substitution instance of the rule. You have to be able to identify and recognize the pattern of the logical operators and the components, and then make uniform and consistent replacements. When you've got an exact match, the rule usage is correct, and if you don't have an exact match, then you do not have a correct usage of the rule. And now let's look at a longer example where I give you specific steps to help you through the substitution instance process. So here we have a proof sequence. And the first thing that you do is you write out your rule form. And again, I encourage you to use colors or shapes. The next step is to determine your substitutions. Now, when you use substitution instances, you don't necessarily have to start with the first ingredient that the rule form gives you. All you're looking for is a specific replacement. In this case, P is the antecedent of the conditional that we're trying to use. So that means it's tilde F. Q is the consequent of the conditional that we're trying to use. And so Q's substitution is tilde N. And then finally, write out the rule using the substitutions. Here we've got the rule pattern again. If you like colors, I've used the same color pattern here as we did down here. And then now we make our substitutions. Now, as you make your replacements, you want to be consistent. P gets replaced with not F. Now we've got to replace this P with our substitution. And here you really want to think copying and pasting, or even just the find and replace function in Word. We want to take P and replace it with our substitution instance so that this is what we're getting. P has been replaced with not F, and the result is tilde F. Now we do the same for Q or green. Q gets replaced with tilde N. And so our first replacement looks like this. And then now our second Q also gets replaced by tilde N. And again, think find and replace or copying and pasting. And this is what we get, tilde N. This was our Q position. And so we replace Q with tilde N. And now we're ready for the last step, which is just to see if there's an exact match between the substitution instance based on the rule and what is happening in our proof. And of course, here we see that we don't have an exact match. And this is indeed an illegal use of modus tollens. If you want more practice, go through the examples in the book and try out the method. Using examples in the book has the additional benefit that you are told whether or not the usage is correct or incorrect. For example, on page 360, you're given this example of HS. Follow the steps. Write out the rule form for HS, whether sticking with P's and Q's and R's or using color coding. Then determine your substitutions. Finally, write out an instance of the rule using your substitutions and ask yourself whether or not you've got an exact match. And in this case, we do, and so it's legal. You can also do this with any of the textbook exercises and the answer keys. And again, using substitution instances is a great way to practice developing your rule pattern recognition skills, to understand why and when a rule usage might be legal or illegal, and then also as a way of self-checking your proofs.